Wondered how materials science affects our daily lives? It's like the hidden hero of our modern world. From the robustness of your coffee mug to the resilience of the car you drive, materials science is at play. It's all about discovering and designing new materials, with a keen focus on solids. The fascinating world of materials science is constantly shaping our lives, even in ways we don't often realize. Join us as we count down the top 10 amazing materials that science has given us. Starting with number 10, we have graphene. Now imagine a material that's as thin as a single atom, yet stronger than diamond, and more flexible than rubber. That's graphene for you, a one-atom thick layer of graphite. It's not just its strength and flexibility that make it unique, but also its exceptional electrical and thermal conductivity. Graphene has been hailed as a wonder material, and it's not hard to see why. Its unique properties have opened up new horizons in various fields. In electronics, it's used to create faster, thinner, and more flexible devices. In energy storage, it's revolutionizing the way we store and use energy, making batteries more efficient and solar cells more effective. But that's not all. Graphene's potential is being explored in other areas too, like biomedicine and aerospace, making it a versatile player in the field of materials science. Graphene, a material truly worthy of our countdown. At number 9, we have the fascinating aerogel. Imagine a material so light, so airy, it's almost like holding a piece of cloud in your hand. That's aerogel for you. Derived from a gel, aerogel is a synthetic, porous, ultra-light material. It's like a sponge, but much, much lighter. With its low density, it's one of the lightest solid materials in existence. But don't let its feather light fool you. This material is a powerhouse when it comes to insulation. Aerogel is used in everything from building insulation to spacesuits, making it a crucial material in both construction and space exploration. This is possible due to its unique structure that slows down the transfer of heat, making it an exceptional insulator. It's hard to believe that something so light can be so powerful, isn't it? Aerogel, a material as light as air but with incredible insulation properties. Next in our countdown at number 8, we have liquid crystals. A fascinating material, liquid crystals exist in a unique state of matter that is a hybrid between solid and liquid. They flow freely like a liquid, yet they maintain some of the ordered structure of a solid. Their molecules can be arranged in different ways, which gives them their chameleon-like ability to change their physical properties in response to changes in their environment. Now, where do we use these intriguing materials? Well, you're probably looking at them right now. Liquid crystals are the lifeblood of display technologies, such as those found in LCD screens. These screens are everywhere, from the smartphone in your hand to the big screen TV in your living room. It's the unique properties of liquid crystals that allow these screens to produce the vibrant, crisp images we enjoy every day. Liquid crystals, the magic behind our screens. Coming in at number 7, we have Nitinol. This intriguing material is a metal alloy, a mix of nickel and titanium that boasts a peculiar property known as shape memory. Now, what's this shape memory, you may ask? Well, imagine a material that once deformed can bounce back to its original shape when heated. That's Nitinol for you. This unique characteristic has found its way into a myriad of applications. In the medical field, Nitinol is a game changer. It's used in stents and heart valves as it can be compressed into a small size, inserted into the body, and then spring back into its original shape. It's also found in orthodontic wires and spectacle frames, ensuring your glasses bounce back even after you accidentally sit on them. Nitinol, a material that can remember its original shape, is truly an embodiment of the wonders of materials science. At number 6, we dive into the quantum world with quantum dots. Quantum dots are not just any dots. They're nano-sized semiconductor particles with a sprinkle of quantum magic. These tiny particles have unique optical and electrical properties that have scientists and engineers all over the world buzzing with excitement. The most fascinating aspect of quantum dots is their size-dependent light emission. Simply by changing the size of the dot, one can control the color of the light it emits. This property is being used to revolutionize display technology, allowing for screens with more vivid and lifelike colors. But it doesn't stop there. Quantum dots are also making waves in the field of solar cells. By absorbing light and efficiently converting it into electricity, they're helping to create more sustainable energy solutions. And let's not forget their potential in medical imaging, where they can illuminate cells and tissues for more accurate diagnosis and treatment. Quantum dots, a material with endless potential. Halfway through our list at number 5, we have self-healing materials. Now, these materials are no less than a marvel of modern science. They possess an intrinsic ability to repair themselves when damaged, much like our own bodies. This is achieved through various mechanisms, such as the release of healing agents or reversible polymerization. Just imagine a scratch on your car disappearing overnight, or a crack in a building repairing itself. The applications are vast and varied, stretching from the mundane to the miraculous. Picture this: self-healing concrete, making our structures safer and more durable, or electronics that fix themselves, increasing the lifespan of our devices and reducing electronic waste. The potential of these materials is boundless, and their development and refinement continue to be a focus in materials science. We're looking at a future where things repair themselves, reducing maintenance costs and extending product life. Self-healing materials, a step towards immortal structures. At number 4, we have the mind-bending metamaterials. These are not your everyday materials. Metamaterials are meticulously engineered to possess properties that you won't find in any naturally occurring materials. It's like science fiction brought to life. Imagine materials that can manipulate electromagnetic waves, including light, to render objects invisible. Yes, you heard it right. Invisibility is no longer just a fantasy. Metamaterials have the potential to make cloaking devices a reality. And if that's not impressive enough, let's talk about super lenses. Traditional lenses are limited by the wavelength of light, restricting the level of detail they can provide. But with metamaterials, these limitations could be a thing of the past. Super lenses could allow us to see objects smaller than the wavelength of light, revolutionizing fields such as microscopy and nanotechnology. Metamaterials, bending the laws of physics. Truly, we're living in exciting times as we push the boundaries of what's possible, one material at a time. On the podium at number 3, we have biodegradable plastics. These remarkable materials are rapidly gaining attention as an environmentally friendly alternative to traditional plastics. Unlike their traditional counterparts, biodegradable plastics are designed to decompose naturally over time, reducing the amount of waste that ends up in our landfills and oceans. They're typically made from plant-based materials like cornstarch, which microorganisms can break down. This decomposition process leaves behind water, carbon dioxide, and biomass, none of which pose a significant threat to the environment. The importance of these materials cannot be overstated. Plastics are infamous for their longevity in the environment, with some estimates suggesting they can take hundreds of years to fully decompose. The widespread use of biodegradable plastics could significantly reduce this pollution, helping to preserve our planet for future generations. In a world increasingly aware of the importance of sustainability, biodegradable plastics are more than just an innovative material. They're a symbol of progress, a sign of a more mindful approach to material science. Biodegradable plastics, a step towards a greener planet. Just missing the top spot at number 2, we have carbon nanotubes. Imagine a world where cylindrical molecules made of carbon exhibit extraordinary strength and possess unique electrical properties. That's the reality with carbon nanotubes. These tiny tubes, 1,000,000 times thinner than a strand of human hair, are stronger than steel and lighter than aluminum. But it's not just about strength. Carbon nanotubes are also exceptional conductors of heat and electricity, making them a key player in the field of nanotechnology. From enhancing the performance of electronics to revolutionizing optics, carbon nanotubes are paving the way for new possibilities. Imagine batteries that charge in seconds, or computers running 1,000 times faster. It's no surprise that they are becoming an integral part of materials science. The potential of carbon nanotubes is immense. With their unique properties and potential uses, they're not just reshaping our understanding of materials, but also redefining the limits of what's possible. Carbon nanotubes, the giants of the nano world. And finally, at number 1, we have perovskite. Now this isn't your typical material. Perovskite is a superstar in the field of solar energy, boasting some truly impressive credentials. What sets perovskite apart? Well, it's incredibly efficient at converting sunlight into electricity, so much so that it's starting to give traditional silicon solar cells a run for their money. But the real kicker? It's far more cost-effective to produce. Imagine a world where solar panels are no longer an expensive luxury, but a commonplace, affordable reality. That's the world perovskite is promising us. And the best part? It's not just a pipe dream. Researchers around the globe are working tirelessly to bring this vision to life, overcoming hurdles and steadily improving the stability and longevity of perovskite-based solar cells. So, keep your eyes peeled for this game changer in the renewable energy sector. Perovskite, a material that might just power our future. And there we have it, our top 10 countdown of amazing materials. Each one, from graphene to perovskite, holds the potential to revolutionize the world as we know it. Material science is not just about the materials themselves, but about how they can transform our daily lives, from our smartphones to our cars, from our homes to our hospitals. So let's continue to marvel at the wonder of these novel materials. Stay curious, stay excited, and who knows what amazing materials science will uncover next.